Hello everyone and welcome back to Just Finish Coding. I'm Sriram and this video is the fourth part of the Jetpack Hero series. In case you've not watched parts 1 to 3, I will leave a card for you right here. Before I proceed, I do want to congratulate you for making it all the way because this is going to be the last and final video in this series. By the end, you will have the in-game explosion and the sound effects completely ready. Before we go into the explosion, there is a bug which needs to be fixed. Remember that the score sprite has 3 individual clones. As long as the score has 3 digits or less, this will work pretty nicely. However, if a person manages to increase his score beyond 999, there will be some big problems. So, we can do all of the existing stuff if the score is less than 999. If it is more than 999, then we switch the costume of every clone to 9 and then we show them. Rather than cutting off the 4th digit of the score, this will make the clones display the costume 9. It isn't perfect as 999 will be basically the max score and we can't display numbers beyond that, but it's still a big improvement. With this out of the way, we can focus now on the player movement following the explosion. We can check for a collision with the rocket at the bottom of the forever loop. This may seem very logical, but if we just program the collisions, there will be a huge problem. If you look at the costumes tab of the player, you will notice 2 costumes, player and player die. The difference is that the player costume has a beam of fire behind him while the player die costume does not. Since the player costume is the one dominant in the game, checking collisions with the rocket would include a collision check with the fire. This would be a big mistake. The game should continue if a rocket hits the fire, but only stop if it hits the player. To fix this, therefore, we switch the costume to player die before the collision check and switch it to player after the collision check. If the player sprite is touching the rocket, then the explosion animation should begin. We will program this later within the explosion sprite, but we need to send it a signal to begin. For this, we broadcast a new message called explosion. When a rocket touches the player, there will be an explosion animation within the player's place and the player himself will be thrown off upwards and then fall down. In addition to the toss and fall in the y-axis, we can add some more additional movement in the x-axis to make the animation more realistic. Just like we used the yvel variable for the y movements, we can use an xvel variable for the x movements. Just like yvel, this will be set for the sprite only. We can set xvel to 40 and yvel to 20. There's no logic behind these numbers and they are based on trial and error to see which animation looks the best. You can modify and play around with these numbers to decide which suits you the most. We will be repeating this process until the player is out of the screen. There are 3 cases in which this might happen. The player could fly out of the screen at the top, he could fall out of the screen at the bottom, or he could fly out of the screen at the right. To make sure that the top and bottom are considered, we check if the absolute y position, meaning y position without the sign, is more than 210. For the right side, we check if the x position is greater than 270. While this condition remains false, we can change x by xvel and y by yvel. To make this motion more realistic, we can apply air friction along the x-axis and gravity along the y-axis. We can set xvel to 9/10 of what it was and then change yvel by -1. To give the resemblance of a missile hit, we can make the player go out spinning. This can be done by rotating xvel by 5 degrees in the clockwise direction. Once the player is out of the screen, we can hide the sprite. At this point, we will be going back into the intro screen, so we can stop the game script as well. Alright, now we can move on to the explosion sprite. When the thumbnail message is received, we hide the sprite and delete all of its clones. All the explosion clones that will be used for the explosion animation will be created upon receiving the explosion message. This means that the clones have to be created instantly within a single frame. We also need to reuse the same code multiple times, so it will be a lot quicker to use a block. We can call it create costume clones and check the box which says run without screen refresh. We can create another block called get explosion coordinates and run without screen refresh. I will explain what the second block does later on. At this point, we have to get the explosion clones to work. Just like we did for the other sprites, we can identify each clone with a unique clone ID. So we initialize a new variable called clone ID for this sprite only. We initially set clone ID to 0. We will be creating 5 clones each time the block is called. So within a repeat 5, we create a clone and change clone ID by 1. Before we proceed, I think it is necessary to give an overview of how the explosion animation would work. If you look at the costumes tab, you will see that there are 4 circles, each of them having a different color. The 4th costume has the brightest color, and the brightness slowly reduces as we move on to the 3rd, 2nd and 1st costume. At first, the animation will consist of just the 4th costume, then that costume will switch to the 3rd one, then that to the 2nd one, and finally to the 1st one. If we just use a single clone and switch its costume 4 times, we will get a decent animation. But to make the animation exceptional, we can add some more things to it. Rather than having a single clone switch its costume, we can create 5 clones of each costume. Instead of all the clones being within a single location, we can make the explosion follow the haphazard movement of the player, though with some variation. Let's get back to the code. The get explosion coordinates function will be used to get the specific x values and the specific y values of the player during the animation of the player sprite. We could use 5 different variables to store each x position and 5 different variables to store each y position, but it's much easier to use a list for each axis. The first list will be explosion x and we set it for all sprites. The second list will be explosion y, which will also be set for all sprites. At the beginning of the function, we will want to clear out the previous values that exist in the 2 lists. We delete all of explosion x and delete all of explosion y. Remember that the player's x coordinates will be stored in the explosion x list and the player's y coordinates will be stored in the explosion y list. So within a repeat 5, we add the x positions of the player plus a random value from -20 to +20 to explosion x. The random values enable us to have some variation. We can do a similar thing for explosion y, but we will use the y position of the player. Alright, let's move on to the explosion message. The code here will be very simple but quite long. First, we broadcast a new message called stop missiles. When the rocket clones receive this message, they will delete themselves. Next, we clear all of the graphic effects of the sprite and then get the first set of explosion coordinates. We first switch the costume to 4 and then create the clones. The clones will take a small time lag to move to the locations in the 2 explosion lists, so we add a wait period of 0.1 seconds. We now duplicate the same 3 lines of code, but instead switch costume to 3. While the 3rd costume will have an identical time lag to the 4th costume, the 2nd costume clones will have a wait lag of 0.05 seconds. We will want the last costume to linger a bit longer than the others, so for this, we set a wait period of 1 second. Once all of this is done, we have to get back to the intro screen. Just inserting a single line of code will achieve this for us, and thus we broadcast thumbnail. Moving on, when the clones are created, we set their X position as item clone ID of explosion X and their Y position as item clone ID of explosion Y. Just like we did for the rockets and the UI clones, we can use the same size animation for the explosion. Initially, the size is set to 0 and the clone is shown. Within a repeat 20, we change size by 500 minus size, the whole divided by 5. This way, the size of each clone increases to 500 within a few frames. After this, we can use our same code backwards, by just replacing a 500 with a 0. This code ensures that the size of each clones decreases to 0 within a few frames. You probably get what these two repeats do together. The clone first enlarges and grows bigger and bigger, and then it shrinks and disappears eventually. After we are done with this, we can delete the particular clone. Let's now make sure that the rocket clones delete themselves when they receive the stop missiles message. We need to first stop new clones from being created by stopping other scripts in Sprite. Then we can delete the clones. Okay, so now let's get the sound effects ready. The first bit can be done either in the UI stuff sprite or within the thumbnail. We can do it in the thumbnail because the code there will be far less cluttered than it will be for the UI sprite. We can start with a when green flag is clicked. This is where we will be adding a mute feature, so that mute feature will be represented through a variable. We can call this variable sound switch and set it for this sprite only. At the beginning, we set sound switch to 1. If it is 1, the sound effects will be audible, otherwise the sound effects will be muted. So during the game, if the M key is pressed, we will change sound switch by 1. Since we are in a loop, the sound switch may have been 0 or 1 at this point. If it was 0, then the sound effects should be changed from muted to audible, but if it was 1, the sound effects should be changed from audible to muted. To get around this, we check if the value of sound switch is greater than 1. If it is, then we set sound switch to 0. The key presses are very sensitive, so what the user may think is a single key press actually turns out to be multiple key presses. To make it easier for the user, we wait until his key is no longer being pressed by him. To get the other sprites to mute their sounds, we create another variable called volume for all sprites. We set volume to be the sound switch multiplied by 100. This should be pretty self-explanatory. Let's now go into the stage and ready the background music. Within a forever loop, we can play the sound until done. We can set up another forever loop in a second when green flag is clicked. Here we just set the local volume of the sprite to the volume variable, and the background game music will be muted if the M key is pressed. There will be a sound effect when the explosion takes place as well, so within a forever loop we set the local volume to the volume variable. This will have no impact if no sound is played at all, so we head up to the explosion message and start the sound after we set up the first explosion list. Alright, that is going to be everything that needs to be done. If you test out your code now, you should have a fully working Jetpack Hero game. If you've enjoyed making this game series, then check out the playlist on your screen right now. Thanks for watching, and I'll see you in the next video.